one but two speakers, Gergely Seres and Benedek Kovács. Gergely is an expert and chief architect of software technology and application architecture at Business Area Cloud Software and Services, currently working with 5G and the Internet of Things. Since joining Ericsson in 1998, he has held several research, technical, and managerial positions. He holds a PhD in electrical engineering from the Budapest University of Technology and Economics in Hungary. Benedek Kovács is an expert for edge computing at Ericsson, responsible for the related network architecture in 5G and 6G, including network services and APIs. Benedek is head of technology and innovation at Ericsson Hungary R&D Center and holds an MSc in information engineering and a PhD in mathematics from the Budapest University of Technology and Economics. The title of their talk, Network Programmability and Telecommunication APIs. Please welcome on the stage with a huge round of applause, Gergely Seres and Benedek Kovács.
Hi, hello. I hope you can hear me, can you? My name is Benedek.
And my name is Gergely.
Welcome, and thank you for joining or speak about network programmability and network APIs. We are from Ericsson, so you know that Ericsson is the one which is building the network so that the mobile phones and the IoT devices and everything can communicate with each other. Basically, we build everything which is between two mobile phones or between an IoT device or a server in Amazon or anywhere else. So in this presentation, what we will present to you is a little bit about network programmability. I will start with a little bit warming up what we have today, and Gergely will introduce us to the novelties, to the new network APIs. So, first of all, why network APIs and why exposure? Why do we call it exposure? The exposure, we call it exposure because we are letting the network data used by applications. So basically, the data that is available at the operators will be available for applications by exposure. So there's the cellular connectivity that basically connects people, connects things, and then there's an exposure layer where we safely, with all the safely regulations that is needed, expose the data to third-party applications to all those who would like to build on this network data. And of course, this is always done by the network operator. So why expose the network data? We are providing security based on the SIM. So basically the same trust that you have with a mobile phone, that the owner of the SIM card has actually gone into the office and actually shown the ID. It's a very authenticated method. So basically we provide security. Works globally, because telecommunication is a global standard, so there are no glitches around the globe. And provides network quality. Then enables new business models. And Gergely will show you about a couple of new business ideas what network can enable. So let's take a look at the architecture. And I promise you, this is the only level we will get in the network architecture. So if you look at the network very briefly, on the left-hand side, you see the mobile device. The mobile device has a platform. And of course, you develop the applications on these platforms, like the Apple platform or Android or others. And then it's in your pocket. When it comes to the network is usually consisting of two parts. One central part, which is a central cloud, and let's say that is your internet gateway, and through the internet gateway you can access the different big data centers, and etc. And then there is a network edge. Network edge is used in either private network use cases, so when it comes to a factory, when it comes to, for example, Rotterdam World Gateway. I think we are proud with Gergely to tell you that we were the architects of Ericsson's first private network solution in Rotterdam World Gateway, where we actually swapped Wi-Fi solution. Why did we swap Wi-Fi? Because of security, which is already embedded in the networks. You don't have to operate an IT team that is actually taking care of your Wi-Fi security through certificates and etc. And the other thing is reliability and the trusted connection. So in the 5G networks and in 4G networks as well, you can configure the frequencies so that you have always the desired quality for certain applications. So that's the big add-on, which you cannot really do on Wi-Fi, because if you bring in other 10 Wi-Fi devices, that might easily disturb the communication. That cannot happen in a mobile network if you are using the right APIs, as we will show. So that's about edge. And let's move on. So what type of APIs are we talking about when we are talking about mobile APIs? We are talking about communication APIs, and that's pretty much the legacy. That's what we have today. And we are talking about network APIs, on the other hand, which we are developing. As you may know, mobile networks are primarily used for communication between people. I mean, today we are using still our cell phones for mobile voice calls and etc. And then I think every one of you have received short messages about the secondary authentication codes and everything. That's all going through the mobile networks. And in 6G, what we are saying is that the mobile networks will become more ubiquitous, everywhere available, and they will become also available for sensing. So 6G is operating on a much higher frequency, and on this much higher frequency, what you can do is actually you can detect movement of objects based on the radio waves. So that is what 6G is about. 6G will expand these capabilities. And the network programmability and network APIs are about exposing these capabilities to the applications so that you can use it. And there are sort of, the favorite use case is that when a child is going on the road, then you can stop the car and this kind of stuff. Of course, this might not happen like remote surgery because it will be always easier to ship a person there. But technically, it's possible. And this might ignite some innovative use cases. OK, so let's take an example, finally. So what you can do already today, it's Vonage is part of Ericsson. Vonage is a network API company. Basically, Vonage, what provides to you is easy APIs to create voice calls in your web browser, to create short messages, to send WhatsApp messages, to verify a user's identity, to look up a number. So when you are actually have a call from a company, then the company name is immediately written in your call without you entering it into your database. It's because of an API, because the API asks it. And then create video sessions. So what does Vonage do really? So Vonage, you can check it out at vonage.com. You can register. There's a free trial you can try out. And basically what you can do is you can reach every mobile network, and you can create voice calls, send SMS, and check numbers in every mobile network around the globe. So there is this aggregation role, basically, because they are interfacing with every mobile network. And that is enabled by the 3GPP standards, so by the fact that mobile networks are standard. So each and every mobile network has the same programmability APIs. So you can find out more at vonage.com. If you would like to check, then it is easy. Maybe at this point, I would have a question to you. Have you ever sent SMS through an SMS gateway? You did. So Vonage does that, but does a lot more than that. For example, for SMSs, you can also get the different know-hows, what to take care about when you are sending SMS to different countries. So if there are any particularities, like how the message will be delivered and how it will be checked. So check it out at vonage.com. And with this, I would like to hand over to Gergely to introduce the network APIs.
Thank you, Bence. And I'm going to talk about this black box that we've got accustomed to being a bit pipe. You throw in data on one side, and it comes out on the other side. Now we're opening up that box so that you can actually get out a lot of information, and you can even control the network. So the mobile network is actually going to be a platform that you as a developer can program over APIs. So let's take an example. You're sitting in a bank, and you're developing an application that is supposed to identify suspicious transactions. And if it is deemed for a fraud, then you try to block the fraudulent transactions. How do you do that? You have all kinds of access to the transaction data. This is business as usual. And you can identify some red flags, if the amount is too high, or the recipient is a new one, never known before. And what you can do extra with network APIs is that actually you can check if this transaction is originating from a fraudulent call. We all know that there are now quite big attacks on individual customers that try to impersonate a loved one and try to persuade the client into making a transaction that, OK, this is needed to save your child or grandchild. in order to get this. And you can do this actually, a quick extra check as part of your transaction processing that, is this number that is my client trying to make a transaction, are they engaged in a call? You don't need to know, whom they are talking to, when they have started the call, but just a status message. And it's already a red flag that it's not really a customary that someone is making a bank transaction and at the same time hanging on a phone. So that can be a red flag that you can add to your existing anti-fraud system that you can use. And if all the red flags are raised, then you can decide to block the transaction. So that's one way of doing this. Either you block the transaction or you do something extra, right? And what is that extra? You typically do a two-factor authentication. That now this seems to be a little bit fishy. So let's make a second attempt and make a one-time authentication.
Maybe just to add to that, I don't know if it has happened to you, but it happened to me in Stockholm. So I used my credit card to buy a metro ticket, and then 5 minutes later, my bank called me that, you used your credit card 2 hours ago at Budapest, now it's in Stockholm. Is it you who is using it? And I was like, yeah, it's me, and I verified myself. But that was quite revealing that, they are taking care of potential identity frauds.
Yeah. And using network APIs, you can take even better care of your customers because you can identify these fishy, fraudulent transactions. The other method, instead of using this one-time password that you send out via SMS, that's a bit problematic because the elderly people have really a hard time using this kind of thing, switching between applications and trying to enter and remember that code. Instead of that, we have a new API that is called silent authentication. In this case, we rely on the fact that each time when you turn on a mobile phone, then we do a really, really strict authentication. Is this really a legitimate phone? And that information is stored in the SIM card of this device. That is a trusted computing module so that you cannot manipulate that. Or if you do manipulate, then it's going to be destructive. So that means that we rely on this authentication and provide you an API you can simply just take on the regular username password authentication, and then instead of sending a one-time password to the end user, you just ask the network, please authenticate this user for me. Is this a legitimate user? Is my application, financial application, running on the mobile phone that it claims to run on? And then we can actually rely on this network-based authentication that is, giving you the trust that it is indeed the person who the person claims to be. So that's another API that we offer. And if we move into the enterprise space, then you might also recognize the situation that, for example, you're sitting on a train, you're traveling to a conference like Craft, and then you have a scheduled meeting that you cannot skip. It's with an important client that is having problems. And what do? You take on your laptop, take out your laptop, and initiate a call via your mobile connection, making a hotspot or whatnot. And it might be all too familiar that in the middle of the meeting, when the client is just explaining the problem, and it's the most important sentence that is containing the root cause of the problem, and then you get this. And then, if you're lucky, then in a second or two, you're going to be reconnected. If not, then you're dropping the call, you have to log in again, and you lost that most important sentence. So this is actually what we are now raising so that we can solving this by having an API call prior to this meeting that allows you to raise the priority of this connection so that if you have people around you, your Teams call is going to be prioritized over the others that are sitting in the same railway car. And this allows you to have uninterrupted connectivity. You can even call another API, and that blocks all incoming calls so that you really have a peaceful time talking to the client. And with a third API call, you can even connect yourself securely to your enterprise data center so that none of your traffic is going through the internet. So you have full security and full privacy for this important meeting. This is a set of APIs that we also offer to realize this. And there's more information about this at the Ericsson booth. So if you would like to kind of get an in-depth discussion, then feel free to come over and visit us in the Ericsson booth.
Maybe something to add here. But maybe this is a little bit secret still, but we are working also on an API which will not only tell you, which will not only raise your priority of your call, but also will tell you in advance if you can make the call within the time frame. So for example, if you are on the train, maybe you get a message early in the call that there will be an interruption in 5 minutes because of network coverage issues and such.
Yep.
So prediction, it's very important, especially important for this smart vehicles and everything, because for example, an automated guided vehicle, it has to be known that it is always reachable and you can always move it in a way. And if there's a problem in certain areas, then you can predict that area there will be a problem and tell the operator forehead so that you can prepare for it.
Cool. So another stint of the same thing. You get to the conference, you're attending a lot of interesting presentations, you got inspired but exhausted as well, and then you want to let some steam off. And then you engage in a multiplayer game or even a cloud-based game. And for all of this, you very much recognize that latency is king. You really need low latency in order to be able to kind of win and be competitive in this situation with your peers. And it can happen that, due to a glitch, you don't notice, for example, that dragon and your whole team is actually losing out on the mission just because, you had a glitch in the network connection. Here, if you're an application developer, you're developing this game, you can also offer this kind of quality of service boost to the end user that, yeah, I see that you're now launching a campaign in your favorite first-person shooter. And then you can just provide a pop-up window that, would you like to boost connectivity for this period while you're gaming? And then you invoke this API. The customer is going to be charged a minimal set. You can keep part of this income as part of your application revenue. Another part goes to the communication service provider. And everyone's going to be happy, right? Because the game is going to be glitch-free as well. So this is the more consumer-oriented approach, complementing this enterprise that we have started with. Now, if we look at a little bit or more detail, we are developers after all. Then you can see that this is nothing magic. So it's just a simple API call. And what you have there is a post request to an endpoint called session. And then it's really easy because you just have to identify the endpoint, which phone we are talking about that you would like to kind of increase the priority of. And then you can actually be really specific that you just want to boost, for example, the Teams connection so that you provide, your Teams application server backend IP address, and you also provide the phone IP address, and you just want to prioritize that simplest flow. Not all the other ones, Facebook and the others that the user might do on the phone, but you just want to raise your connection that is of interest to you because you're the application developer for that part. And then you can also specify a time box, how long this boost should last. And then what you get back is basically your request, repeating that, OK, this is what you have asked for, and then a confirmation that, OK, the quality of service boost, raising the priority in the network is applied, and this is for how long it is going to be valid. And what happens actually under the hood is that in all kinds of wireless communications, it is the radio link, the radio waves that are the bottleneck here. That's the thin pipe there that here, for example, in a conference center, you might notice that your internet data is a little bit slow because there are quite many people in the same radio cell that we have here. So what we're doing here is actually creating prioritized bit pipes over the radio link. And this is what you control, that if you invoke this API, then your application is going to be channeled into one of the priority links, either prioritizing for latency or throughput, or actually both. So that's actually how it works, and it's really simple. From your end, as an application developer, it's just a simple post request. That's it, and no magic. You don't have to know, any internal details of the telco network for this to work. Cool. And this was only a subset. So we have introduced you, 3, 4, 5 APIs out of this list. But there is this alliance that is called Camara Telco API Alliance. And they are the ones that make sure that these APIs are independent of the mobile operator. So you don't have, operator A, operator B, and C, on some other component, operator X, operator Y, coming with different APIs. That would cause a headache for you. But now these are standardized in Camara Alliance, and that means that you can use the same API regardless, where your end user is located in the world. So that's the whole point. And as you can see, there are loads of things. You have even more anti-fraud APIs, like, for example, SIM swap, letting you decide, for example, if the SIM card has been changed in the phone. That's also, a typical fraud, that they redirect SMS messages, and then the one-time passwords that you send as a secondary authentication, they are intercepted and used by someone else, the malicious actor. You also have device location, for example. You can actually check where the end user is located. If, for example, Bence is flying from Budapest to Stockholm, then you, as the back end of the financial application, can detect, Bence's phone is now in Stockholm, so I don't need to make a call just to make sure that he is indeed in Stockholm, because I know it from the location of the phone.
I would have survived that call.
Yeah, sure, okay. But anyway, lots of things, know your customer, business-oriented APIs, and a lot more. I really encourage you to explore the capabilities, because, as I mentioned, this black box, the telecom network, is now opening up and offers you a lot of programmabilities. Another thing that is important is that all the mobile operators have this alliance that is called the GSM Alliance, or GSMA in short. And they have also made sure that these APIs are consistently introduced all across the world. So you have a number of these APIs that are coming from this Camara Alliance that I was talking about just before. You have GSMA connectivity-related stuff, and then you have also from TM Forum, which is the Telecom Management Forum, all these kind of APIs that you can use to program the telecom network. And they are offered via this GSM Alliance in a unified way all across the world. So this is your way of getting to the APIs. And if you go to their homepage, what you're going to see is this one. This is the list of countries where the telco APIs are already available. And if you click on each and every country, you get a list of mobile operators and the specific APIs that they currently support. And remember, if you see, for example, the device swap API or SIM swap API, then that's going to be the same API, regardless of which country and which operator is realizing that. But here you can see that already a large number of countries have rolled out these APIs, and you can see which particular API is available in which country. Okay, so in terms of summarizing what we've said, we are opening up the telco networks so that they are no longer a black box. And you can program these. Your apps can actually initiate communication. We have the communication APIs for that. And for that, we have Vonage. And remember, developer.vonage.com. You can get up to speed and send SMSs, send messages, initiate voice calls, initiate video calls. You can do that all in 5 minutes. You get a credit so that you can experiment with the APIs. And immediately, in 5 minutes, you can send an SMS to yourself or to anyone, basically, in the world. And the good thing is in Vonage is that they hide this complexity of which country and which mobile operator the end user is located in, and which operator they have a contract with. You just deal with Vonage, with their set of APIs, and it works globally. So your application is going to be getting a global coverage. If you would like to go for network APIs, you can also use the Camara APIs. In that case, you can use these operators from the GSMA homepage. And then you can actually raise the priority of your connections. You can get device status, like if they are engaged in a call or not. You can do number verification. For example, this silence authentication that I was talking about. And you can detect SIM changes, another red flag for fraudulent transaction identification. And also you can get location information. Now that is actually a GDPR-sensitive topic. We have these privacy rules in Europe and also in California. And there you have to make there you have to use another API that is giving you consent to use this information. Or alternatively, there is a scaled-down version of this location API where you can make a very specific query. Is this particular person attending the Craft conference in Budapest? And then you get a yes-no answer. So you really have to have a very, very precise assumption where the user is located. And that is, for example, used for financial transactions. You really know the location of the POS terminal where the bank card has been applied. And then you can make this very simple query. Is this guy really right next to the POS terminal? And then you get a yes-no answer from the network, so that you cannot guess the real location of the user unless you have a clue. And you need to have a really strong clue to be able to get that. So there are all kinds of variants. Either you get consent, or if you don't have consent, then you have to be really precise to be able to use this location API. Cool. So what we would like you to take away from this talk is that these APIs are available right now as we speak. You can go to developer.vonage.com and get up to speed in 5 minutes. And you have a whole deal of APIs that are available to you, both communication-wise and opening up the network. Cool. That was it. Thank you very much. And we open up for questions.
Thank you. Thank you very much. Here's the QR code. If you haven't asked your questions yet, you can do so now. There's already a couple, but you can still send more. Let's see the questions. Let's get started. They're just going to appear here, and I'm going to read it out so that everybody can hear them. Yes, here we are. OK, so whichever of you would like to answer, you can just, I don't know, first come, first serve basis. You mentioned the Camara API Alliance. Why are ISPs letting someone else set the network priorities for their clients?
OK, shall I go ahead? So, yeah, it's the mobile network operator. So if you recall that figure, in the mobile network, we have limited resources. We have the frequency, which is the radio resources, that is the most limited. Within these limited resources, you are able to manipulate. According to net neutrality regulations, there are regulations what you can manipulate and what you cannot. And of course, these APIs are adhering to that. And when you are practically, when it comes to the ISP, so on the internet, you are not modifying anybody's access to the internet. So the best effort access is always there. So basically the connectivity from the network to the internet stays the same. Nobody is configuring that one. What you are configuring is the quality of service on the last mile of the session.
All right, thank you. You still have a chance to ask your questions. Still have a little time. Let's see the next one. Microtransaction on network. Who are you, EA? What about network neutrality?
Yeah, very good question. Again, as Bence said, this is a sensitive topic because we have all these kind of regulations. But the way it is set up is that companies cannot subsidize network operators to prioritize their traffic. But if a user is subscribing voluntarily that I'd like to have in my data plan like 2 hours of data boost every month, then that means that it is you who decide that you would like to subscribe for this premium connectivity. And that means that it is your deliberate decision. It is not, some really powerful big company that is pushing down the operator to prioritize their traffic, but it is your conscious decision to prioritize this and that application provider, and it is your choice. So you're not forced into, big hyperscaler, rather than even a small company can make use of this feature. So that's, one way of setting it. And there are others, but the explanation for that is long, so please come and visit to us for the longer explanation.
Maybe just one more comment to that. So SLA to the user. So basically, if I go to my mobile operator, I agree on a contract what type of mobile internet connection I will have. That's never violated. Okay. So the way mobile operators are using this is because we are opening up more frequencies, 5G frequencies, 6G frequencies. So there is more resources available, and they would like to use these resources in a smarter way than they did in 4G, 5G timeframe. But your SLA, your contract is still the same. So for an individual user.
All right, thank you very much. Very last chance to ask a question. Looking around, or as the gentleman mentioned, if you want to discuss it in depth, feel free to reach out to them. They're going to be here for a while. And in this case, a huge round of applause for our presenters. Thank you very much for being here with us. Enjoy the rest of your stay here at the conference.